When we're determining the number of solutions, really we're focusing on the slope of the two relationships. So when I want to know the slope, I can look at, I can't necessarily calculate the slope very easily, but I can see that slope ratio with the coefficients on A and B. So here are the coefficients on A and B here, and coefficients here. So seeing that these ratios are different from each other indicates that these slopes are different. So they have two different slopes. So the only way that they can have the number of solutions that can occur if they have two different slopes is that they would only intersect once. Okay, so I don't actually have to solve this equation to know that there is one intersection, which means one solution. Okay, now the other possibilities then work out to be that you could have parallel slopes, and parallel slopes have two situations. Parallel slopes could be no solutions, or they can lay on top of each other and be infinite solutions. So that's the other situation here. So when I look at the next equation here, I have the ratio of the slopes is a to negative b. Here is 3a to 3b. So if I just move this over, I can kind of see that the signs are going to match. 3a minus 3by plus 10 equals 0. So these are in direct proportion to each other. Okay, the signs are the same. These are parallel lines. So 3a to negative 3b is same as a to b ratio. Now, so these are parallel lines. Now they're parallel lines that are separate or on top of each other. We establish that second part by looking at the coefficients. Okay, this equation is 3 times bigger than this one, yet the coefficient is exactly the same. So the constant coefficient is not in proportion to the other coefficients, so we can say that these are two different lines. So these are two parallel lines that do not meet, that are not the same, so they do not meet. So parallel and do not intersect. Therefore, 0 solutions. And again, we don't have to go about solving this either. We can just figure out based on the slopes, we can determine the number of solutions. And in this case here, if we tried to solve for it, we'd have a bunch of A's and B's in our solution. So that would complicate things a little bit, although it can be done. Looking at this last balance here, we have apples, bricks, and circles. And what we're trying to do is figure out how many apples will balance one brick and how many apples will balance one circle. So what we could maybe do is we can solve the bricks in terms of the apples and the circles in terms of the apples. So we want to be able to maybe get rid of some bricks or some circles. So what I'm going to do here is we're going to take this equation. So I have 3 bricks over here, and I'm going to write like this. 3 bricks is equal to 6 circles plus 6 apples. So I have 3 bricks over here. I have 2 bricks over here. So what I'm going to do is do this. I'm going to take this balance, and I'm going to multiply this by 1.5. And by doing that, I'm going to end up with 3 bricks. Now, I'm going to end up with part apples. So I'm going to end up with 7.5 apples. But that's okay. I can put half an apple on this balance. And what I'm going to do is replace these 3 bricks here with 7.5 apples and 3 circles. And that's going to balance 6 circles and 6 apples. And by doing that, I can figure out how many apples will balance one circle. So I'm going to subtract 6 apples from both sides. So I'm going to end up with 1.5 apples on this side. And I'm going to subtract 3 circles from both sides, and I end up with one circle is going to equal 1.5 divided by 3, which is 0.5 apples equals one circle. Okay, so once I figured out how many apples balance one circle, I can figure out how many apples will balance one brick by getting rid of the circles in this equation, or the other equation, could be either or, and see how many apples match one brick. So I'm going to just replace these with apples, and then we're going to be just talking about apples in this balance. So I end up with 3b. 3 bricks on this side is going to balance 7.5 apples, plus, instead of 3 circles, I'm going to replace those 3 circles, each circle, with half an apple. Okay, and by doing that, now I have just apples on this side. I'm going to then figure out how much one brick weighs. So I have 7.5 apples and 1.5 apples. Well, that's 9 apples in total. So one brick will balance 3 apples. So in essence, I've solved this system. So we can kind of play around with the bricks and stuff on this, but in essence what we're doing is we're solving in terms of the apples. So the apples are almost like they are our ones in our regular balances, and bricks and circles represents our x and y's, our unknowns, what we're actually solving for. So when it says solve how many apples will balance one brick, we're basically solving bricks in terms of apples. So apples isn't really a variable. And apples for one circle. So again, the apples in here are going to express the circles. So the apples we're not going to treat the apples as variables, but the circles as our unknowns that we're solving for, and the brick as our unknown that we're solving for.